I would like to welcome you on behalf of Dell EMC and NVIDIA. So I'm at NVIDIA, the Dell EMC Partner Manager. We work very closely these days on opportunities in data science, exactly what was described in deep learning, in data analytics. And this is something, and when I was listening to the previous discussion, so I'm lucky. I'm just in this small part of technology that hopefully helps you to enabling getting faster insight and getting something out of your data. And I don't have to deal with all this politics and this internal things that we often see with customers, of course. But we just come to you and tell you what the technology can do for you. And please feel free to ask questions and to see us also at our booth in the exhibition. I have 30 minutes. So what can I tell you in 30 minutes about AI, deep learning, machine learning, and data analytics? I just can scratch the surface. I have to keep it on a high level. I would also like to point out that in the afternoon, one of my colleagues who is based here in Stockholm is going into more details, especially on deep learning. But we are here all day to answer your questions. So I will focus primarily on two topics, data analytics and deep learning. And I was attending a data science and data analytics event in the US just a few weeks ago. And we were the first time at this conference. And so we were all wearing these NVIDIA shirts. And the people started asking, so we know NVIDIA, you do these gaming cards. So why you are here? What's the solution that you can bring to us? And so just to give you a quick overview of what we do and what the area is that we focus on, I've got a small video, and instead of telling you how good we are in marketing or what the revenue is, just have a look at the video that we use for our GPU technology conference.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years. Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present,
helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
So a GPU had been invented by NVIDIA about 15 years ago with the main purpose of driving pixels on displays for allowing people to play games and to be very interactive within a 3D scene. And based on this idea to have many pixels being driven in parallel on a display, we took this idea to accelerate computing for those algorithms that can be parallelized. This was the origin of CPU-accelerated computing combined with computer graphics. And now we focus very much on this area of AI and deep learning in particular. To look into the capabilities that allow us to do these things, it's a small comparison of what the CPU can do and what the GPU can do. And we do need CPUs, of course. We need to run operating systems. We need to manage devices. But the architecture of a GPU is so different, and we are so highly focused on three key things. When we develop a new architecture and introduce that to the market, we almost double the performance, but we do not just double the performance, we keep the energy consumption, the power consumption on the same level. Or even if we look at our latest product that we have introduced this year, our Pascal GPU, we were even able to do this huge step in floating point performance from around 3 teraflops up to 5.5 teraflops double precision by reducing power consumption from 300 watts down to 250 watts. So that's our main focus, and the gap between the floating point performance of a standard CPU and the GPU is widening. And for the things that we discuss here in AI for deep learning, we don't even talk about double precision, so we talk about single precision or even half precision capabilities. And we achieve with our P100 product right now around about 20 teraflops on a single chip. Based on this architecture, we see developments, especially in data analytics, that have already evolved and that have already implemented at customers. And I'd like to talk a little bit about the history of it and why it's so important to us to talk about at a data analytics conference like this one here. So if you look at the history of databases, in the 80s and 90s, everything was dominated by our RDBMS systems, which then turned into the idea of having in-memory database solutions to speed up the time to find analytics results. And in parallel, so we've seen these developments of non-SQL databases to overcome issues that you find in SQL databases. The Hadoop Framework came up, so many people have a hybrid area, and I remember this blue box this morning. The blue box scenario fits very well into how we look at the market with our new vendors that have started developing GPU-based databases. It's a combination of in-memory database plus utilizing the things that I mentioned before, the capabilities of a GPU running databases. And there are a couple of partners already on the market, and I will talk about Kinetica and MapD in just a minute. But before I come to that, what's the value proposition, what's the unique technology that these GPU databases have in common and that they use? It's to utilize the parallelism that the GPU is bringing to the table. So we talk about around about 4,000 cores in one GPU. So this gives you capabilities to crunch numbers much faster than on a serial task focus CPU. But the other part of the equation is memory. So just if you look at the memory capability and the high speed of a graphics memory, which is completely different to a host memory that you find in your today's servers, we talk here about 5,000 megabyte per second I/O bandwidth, and you can scale that with our new technology. And the third part is, once you use a GPU to accelerate your computing and to get data in and out, then you can also use the GPU to visualize your results. And visualization was also coming up in today's presentation this morning in the discussion. So to visualize results is important, and also supporting people with mobile devices that don't have graphics capabilities in their mobile devices leads to the idea, if I do my visualization and my rendering on the server, I can just stream the results to a mobile device to provide access to data also for people that travel and use mobile devices. The origin of the first example I want to explain a little bit was with the US Army. And behind the US Army, NSA was interested in having a tool in giving in hands of researchers and people that wanted to get hold of, let's put it that way, suspicious people, to find terrorists, to find attacks from data that are available. But there are too many data available, and people didn't really know how to deal with it. They used at that time, and we talk about 2011, 2012, an Oracle spatial database, which took about 90 minutes response time on a very large, high complex query. And then a team of people started thinking about there should be a way to do it better. And this team was incubated in the US Army and developed a solution that was squeezing this response time to below 1 second. And this was amazing. Everybody was, they couldn't believe it. And so later on, though, they deployed the solution, and later on they created a company and they built a commercial product which was called GPUDB and turned into Kinetica today. So Kinetica is using or has deployed this solution also in commercial entities. And since 2014, they got the permission from the US government to sell the solution worldwide. And they have operations now in Europe as well. So for people who are interested in looking at it, I hope I have the time that I can just show you a little bit what they do and how they do it. This is an example of a Twitter analytics database. It has, as you can see here on the left-hand side, 3.8 billion records. And if I just enter, let's say, Stockholm, to have a look, who's tweeting in Stockholm. So you see, in just 1 or 2 seconds, the result is not just found, it's also rendered and visualized, and the record count went down to 2.4 million from 3.8 billion. And also full text search is embedded. So if you want to know who's tweeting about beer, for example, that could be popular, I don't know. That's still quite a few people, but also again, within 1 to 2 seconds, you see the result of 2,600 tweets. We run the demo over there and at our booth, and if you're interested, please come and we can talk in more detail about it. The architecture is also, I think, very much corresponding with the blue box we saw this morning. Because the important thing is, it's a new solution, it's a new tool, but it fits into an existing environment. There are interfaces available, like Apache Kafka, for example. You have APIs that you can deal with C++, with Python, with languages that are in use and that are commonly used. You have other integration scenarios, and you can also use standard visualization tools. If you have Tableau or other solutions, they can fit in and can be connected to this solution. The visualization capability is also connected to what we call GIS, so geospatial or geographical information systems. So you saw that in this example with the tweets. There are other opportunities if you think about geospatial intelligence that is in use not just at agencies, law enforcement, military. It's also important for marketing. Right now, Kinetica is deploying a solution at Walmart. So Walmart is the largest retailer in the world. They have a multi-million SAP HANA installation, and right now they deploy Kinetica, where they combine also very innovative technologies. Traditionally, a retailer is interested in managing inventory, tracking sales, doing the logistics, but today, the marketing department was very excited about the opportunity for feeding in, for example, Twitter tweets, to have social media analytics combined with their traditional sales model. So if people start tweeting about rain, for example, so then they could do more research on which area is affected. So then they can feed in also weather forecast data to figure out where this rain is heading to, so that they can send special coupons to customers to say, Mr. Customer, rain is coming, so we got a special offer for you for umbrellas, for wipers, tires, whatever it is. Just the idea to have sub-second response time in a system with multi-billion of records, that's something that is amazing. And combining streaming data and analyzing those data on the fly. Another partner I want to mention, a company called MapD. MapD is a spin-off from MIT, so they started developing a solution because they were, at the time when they had a research project on data analytics, they were so frustrated about the response time and the performance of all the existing technologies that they started developing very much the same idea, having GPUs used for data analytics. It looks to you as a data scientist like a SQL database. It is a SQL database. You can use standard SQL statements, but it also has, similar to Kinetica, JDBC, ODBC interfaces, so you can connect to other databases as well, and you can use it from your console or from other applications. They have special techniques also for visualization, and very interesting to have a look at this solution. The performance is incredible. They did a first reference, a case study with Verizon. So telecommunication is definitely a market that is highly interested in this kind of solution. Right now we see opportunities with both partners for financial services in the area of security that I mentioned earlier, but also the energy market. So we had this interesting example from Statoil, so oil and gas, energy in general, transportation and logistics, and retail. These are all, let's say, old industries, to rephrase what we discussed earlier this morning, old industries with real products to sell, but using new technologies to analyze what's going on in the market and to plan and predict. And just recently, since this is an exciting area, and I come to deep learning later, we announced 2 weeks ago a strategic partnership between NVIDIA and SAP. And guess what SAP is doing in the future with this technology to combine that with their existing products. So I can talk a lot about the beauty of GPUs and what the performance is, but this is a great example and provides you evidence from a blogger. I don't know, who knows Mark in the audience? Just one. This is a very interesting example. So Mark is a data analyst. He used to work for many Fortune 500 companies in the data analyst space, and he runs his blog, and he has published a benchmark using MapD and a TaxiRide analytics tool, where he's publishing about 50x better performance compared with an SAP HANA installation. We've seen at the Walmart installation performance increases that goes in the thousands. So people do not talk about it because they think if I would talk about these numbers, everybody would think I'm crazy. Just have a look at it, and we certainly can work together with Dell to enable you with the test hardware if you're interested in testing it. Testing with your own data is better than just believing what I tell you. Deep learning as the second part of my presentation is an area of academic discussion. So where does deep learning fit in? So what is it? Is it something new? How does it relate to AI, machine learning? So the way we consider it, so I don't say it's the truth. It's just how we look at it from NVIDIA. So we see artificial intelligence as the overarching topic, where everything that enables machines to learn is embedded, and the idea of neural networks is not really new. If you look back, machine learning neural networks have been, people talked about neurons and using the same technology that we have in our brain and doing that in software and hardware in the early 80s of the last century. So, but with the usage of GPUs, the idea of deep learning was born because then people were able to have more layers in their deep learning technology to complete a task. So that's our view on it, and the way it works is quite simple for those people that have not looked into this area. I know the audience is very mixed, so I had the opportunity to talk to some of you last night. So there are people that are interested in this area, and on the other hand, there are people that are very, very familiar with it already. Just for those that haven't looked into detail yet, the way it works is like here as an example for image recognition is so the machine sees a picture and it starts identifying edges and differences in the grayscale or in color. Then in the next layers, it looks at them of the frames and it puts together them details so that at the end the system recognizes, okay, that's a Volvo. I loved the picture this morning at the end of the first presentation with the Volvo Uber car. And we are here in Sweden, and I don't have it because I'm here in Sweden. Volvo is a great partner of NVIDIA. They announced at CES earlier this year to have the first autonomous car coming to market beginning of next year, which is great. And autonomous vehicles in general is a great topic for NVIDIA, and I can say we work with all the car guys on technologies to enable them to run this. And this shows you two aspects of the deep learning technology. There is one part that is to train a neural network. That's something that happens on larger servers and on clusters. And then you have the other part that's called inferencing. That's when you have a trained neural network that needs to deliver a result of what's going on here. And if the result is good, then we talk about a high accuracy of the result. And at the video, you may have heard this phrase of superhuman results. That's something that people didn't really believe that happens very quickly. But we have seen in a very common competition called the ImageNet that machines are now able to recognize images better than humans. The human error rate of a very well-trained human brain is in the range of 5%. So that means 95% we are able to recognize an image, to detect the objects in the image, etc. So in 2015, the first team that broke that was Microsoft Research. They went below this 5%, followed by Baidu and Google, and this year again Microsoft accomplished a 3.6% error rate with their ImageNet implementation. And the interesting part is, so we haven't, as NVIDIA, we haven't planned really to go into this area. It took us on accident. When Stanford had this project at the very much same time as Google was running Google Brain in 2012, the conditions that the capabilities that a GPU is providing meet very much the conditions that a neural network requires to run. It's not just the flops, it's especially the parallelism and running matrix operations very, very fast to reduce the time to train a neural network. The other requirement, and why we see an uptake these days on deep learning, is that we all see a huge increase in the availability of big data. And the more data you have available, the better you can train a neural network, and the higher is the accuracy at the end if you use it then for inferencing. That's a very, very important part. So if you want to train a neural network, you've got to make sure that you have many data available to train this network. The use cases that we see spread from object detection and scene recognition over, we saw this example with speech recognition, also language processing, translation services, whether it's Skype from Microsoft, or we saw this example with Baidu. So speech to text, translation services, etc., are more and more based on deep learning. Autonomous driving wouldn't be possible without deep learning technology, and most use cases we see in the industry already on deep learning is in medical imaging, and in general medical predictions are very important. And the result of a very well-trained network is, if you think about images and image recognition, to look at the scene like this here and not just recognizing there's a person or that's a human. It's really identifying many more things. It says here 2 young girls are playing with Lego. That's a great accomplishment already, so that you can automatically detect objects and scenes in images. So I would like to, this is something we can go into more detail in the workshop. What I definitely would like to encourage you is to see us at our booth, to have a discussion there, but I think we are up to take questions from the audience, right?
Thank you, first of all, Ulrich. Give Ulrich an applause.